Hey there, stats students. Today in this video, we are going to talk about measures of central tendency. So we're going to talk about what these things are, and then we will go over a few examples of how to calculate them. All right, so first of all, the next couple of videos are going to be sort of exploring the differences between measures of central tendency and measures of variability and why we need both of those things. So to give you an illustration, here's an illustration. So measures of central tendency, as the image sort of suggests, are measuring the ways in which things tend to gravitate towards the same central tendency. So measures of central tendency are taking a look at what are the ways that these numbers that we have, these statistics we have, what are the ways in which these things are similar. Both of these, the purposes of both measures of central tendency and measures of variability is really to represent data. So if we collect a whole bunch of information, collect a whole bunch of survey responses, whatever our data points are, count a certain number of people who are doing certain things, and we have all of this information in front of us, how do we start to share with other people about the information that we're finding? So measures of central tendency and measures of variability are the primary ways in which we do that. Measures of central tendency, again, are going to be showing us the ways in which these numbers are similar. So of our giant whole spreadsheets worth of data, all of these numbers and data points that we've collected, what are the ways in which our findings are similar? What are the ways in which people are similar to one another in whatever it is that we're measuring? And variability, as the word suggests, takes a look at then, and in what ways are they different? So variability, classroom height, playground height is a good example to explore variability. In a second grade classroom, for example, all the kiddos in that classroom are going to be sort of similar in terms of their height. The height is going to vary a little bit, but not a ton. And yet when you see a playground at an elementary school, now you're seeing kids from kindergarten all the way up through 6th, 7th grade. So we're going to see a lot more variability in height. Height is a good example, a good way to think about variability. So central tendency and variability, essentially exploring two sides of the same coin. It's a way of getting to know our data a little bit better, and how do we start to make these numbers in a spreadsheet actually real and applicable. So the measures of central tendency are probably familiar to most folks, mean, median, and mode. We'll go over both of those and what they mean a little bit more, but again, in statistics, a helpful thing about statistics is that the words often sound like what they mean. So mean, not so much. Like mean means the average. Probably we've heard that in some places. That doesn't really sound so much alike. But median and most, the ways that I've been able to remember those terms throughout time and the differences between them, median sounds sort of like middle. When we're looking at the median, we're looking at the middle point of a data set. What's kind of the middle case in our data set. And mode sounds like most. So mode is going to represent the response or the data point or whatever that is most common among the people that we're studying. If we're taking a look at height, then the mode would be whatever height is most common for the kiddos who are attending that class or that elementary school or whatever. So on the other hand, measures of variability, the two most common we have for that are range and standard deviation. We're not going to go into those in this video, but we will do that in a separate video. We also see variance talked about as a measure of variability as well. Variance is not used very much, so that's why I put it in parentheses. It is used, but it's not used on its own very much. When we're simply reporting information, trying to kind of paint a picture of the data that we've collected, variance in and of itself, variance on its own is not an incredibly helpful measure. It's most often used in more complex statistical analyses. So yes, again, we'll have a separate video talking about the measures of variability a bit more. This time I want to focus on the measures of central tendency, but I do think it is helpful to sort of go into this understanding the difference between central tendency versus variability. Why do we have to calculate both of these? How do they complement one another? Something we'll talk more about as well. All right, we are getting introduced to statistical symbols slowly. We are taking baby steps in. Here's a few to know as we are talking about measures of central tendency. These are going to be the same for measures of variability, but we're going to have a couple more for variability that we'll talk about in that other video. So this first symbol, this thing that looks kind of like a E, like a Greek version of an E, it's the summation sign. So the official title, the official word for this symbol is sigma. It essentially means add all these things together. So with statistics, with these kinds of symbols, what you have to think about is that these are essentially like stand-in representations of the actual numbers in our data set. So sometimes a statistical symbol is giving us a command, like it is in this summation, this sigma sign here. Sometimes it is a placeholder for an actual number in your data set. When you see the summation sign, know that it's a command. It's not representing a specific number in your data set like some of these other symbols are. Rather, it's a command. It's telling you add all these things together. So we'll look at this applied a couple times in this video. So hang in, we're going to do a quick simple overview and then we'll dive into the application of it. When you see a big X, that usually means, though not always, depending on what kind of math you're using, and for the purposes of this video, for the purposes of measures of central tendency, variability, etc., when you see an X, it is talking about each individual score in your data set. So of course that can be overwhelming. If I've surveyed like 300 people, that's a lot of individual scores that I'm going to have. If I have to add them all up, that can be a lot of work if I'm trying to do that by hand. Luckily, we have fancy statistical programs like Excel that will do it for us. However, in this video, we'll try this out with a smaller data set. So if we only have like 5 people we surveyed about something, no big deal. We can take a look at each individual person's score. So again, we'll come back to the application of this, but when you see the X, that's what it's asking for. So this would be an example of, it's not giving you a command here, it's actually a plugin for every single score in your data set. So if we just had, so let's just look at the 2 symbols that we've got right now. If we had a sigma sign next to an X, if both of those symbols were right next to each other, what do you think statistics would be asking for you to do? So think about it for a second. Hopefully it's clicking that what it would be asking you to do is to add up every single score. So if you saw, and we will in the next slide, if you saw a symbol that said sigma X, it's asking you to add every single score all together. So we've got a combination of these symbols. That's how they kind of communicate what they want from us. Now, when we see an X with a bar on top, it has the fancy title of X bar. And what it's referring to there is the mean. So this is a more specific, probably easier to understand example then of how you would see this X bar in an equation. What it's asking you to do is to swap out that X bar symbol with the mean. So you'd want to, of course, you'd have to figure out what the mean is, and then when you calculate that number, you just swap that, you'd stick that in the place of the X bar. And finally, n. This one might be a slightly more familiar one to folks as well. A little n is referring to the size of the sample. A big N means something else that we'll get into a bit later on, not in this video. But when you see a little n, it's referring to the size of the sample. So we have to think back to sample population. What do those terms mean? A sample means the number of people that you got information from, or the number of things you are studying, the number of dogs in your study, etc. So if you see a small n, it's referring to the size of the sample. Again, it's a simple swap. You just count how many people did I interview, or how many data points am I representing here. If there's 20 responses, then my n is going to be 20, and I'll just stick in the number 20 anytime it says little n. All right, so let's apply these things. We'll take it slow. We're going to work this out a few times. What I would say as well is I'm going to do several different examples of how to calculate the mean, median, and mode based on a number of different random numbers, random data points that I was hypothetically interested in gathering, aka I made it all up, such as number of candy bars eaten this week. So we'll apply this again and again and again. Feel free to keep watching this video as long as you find it helpful. Once you feel comfortable with calculating these numbers, then you're free to dip out as you would like to. So, okay, in this first hypothetical example, I am interested in student consumption of candy bars or people's consumption of candy bars, something like that. I've asked 5 people. My survey includes 5 people. So I've asked 5 people, hey, how many candy bars did you eat this week? Person 1 ate 3, person 2 ate 3, person number 3 ate 1 candy bar, person number 4 had 5 candy bars, person number 5 had a rough week, they had 8 candy bars. All right, so we are interested in calculating the mean, the median, and the mode for these people, for my data set of 5 people. Here is our lovely equation for the mean. Take a look and see what you think this is telling you to do. If you remember algebra, you'll see the same sort of notions represented here. If you don't remember algebra, that is totally okay. We will walk through it too. All right, so if you can remember from the previous screen, we've got an X bar here. So this is telling us, here's how we're going to calculate the mean. This is how we're going to find the mean. X bar, the mean, equals, and then it wants me to do all this stuff. So I have to calculate the mean. So as you may recall, on the previous slide, I asked you, what would it mean if you saw sigma next to a big X? So here we have that in practice right now. We have sigma next to a big X. It's telling us add up all the individual scores in our data set. Luckily, because we only have 5 people, we can do that pretty easily. And N, what would N be in this situation? Hopefully you were thinking it would be 5. The sample size is 5. You are correct. So here's how that would look. As you're watching this video too, if you aren't already, I would encourage you, get a notepad, get a pen, get something you can write with, because I will ask for you to be doing these equations before I reveal my answers, so that way you can have some practice time to apply this information to. You know, it's really easy to watch somebody else do it. Doing it ourselves is quite a bit different. So I'll actually invite you to pause the video at various times. This time I kind of want to just do an overview trial run. But in the next time we apply this, I'll ask you to pause the video. I'll ask you to write down on your notes, see if you get the same answers I do. Hopefully you do. And if not, at least you'll kind of understand why. The other thing I should preface this with, I've mentioned this in previous videos before, math has never been my thing. I really love statistics because I think it is a really helpful tool in understanding the world around us, and I love understanding the world around us. And math has never been a personal strength of mine. So all the calculations we're going to do, the numbers you see on the screen, I still use a calculator. With simple math equations, sometimes my brain doesn't compute them very easily. So know as you're going through all of this that please use a calculator, have something available to you. The purpose of statistics is not to become a math magician and that suddenly you can do all this complex math in your head. That is not the purpose of statistics. The purpose of statistics is to figure out, how do we make meaning from this stuff? How do I look at a whole bunch of numbers? How do we look at these 5 different numbers on the screen and start to make some sort of meaning out of it? So as we're going through this, I don't think there are any errors in my math, but if there are, know that is unintentional, and grant me some grace as well. Math doesn't have to be your forte in order to understand statistics. So I'll be a real life example of that for you. So if you are following along with pen and paper or pencil and paper, whatever you've got, hopefully this is what you're drafting out. So then we would want to do the math. So if you need to add 3 plus 3 plus 1 plus 5 plus 8 into a calculator, that is okay. Hopefully you'll get the same thing I did, 20. So then we just have to divide 20 by 5, and we get 4. Again, use a calculator for any and all of that. All right, we've got our mean. We have calculated our X bar. We've calculated our mean is 4. The average number of candy bars eaten amongst this group of 5 people is 4. So now, instead of telling my friend, hey, I did this candy bar study, and person 1 ate 3, and person 2 ate 3, and person 3 ate 1, and person 4 ate 5, and person 5 ate 8, now I have one simple number. I can say I surveyed 5 people. They ate an average of 4 candy bars. Simple. Now median tells us something slightly different. Median is the middle point of the numbers. So it is sort of similar to mean. It's sort of similar to the average in that it's giving us a bit of information about kind of a common point amongst all of our data. It's a little bit less meaningful than the mean. So let's calculate it and let's see what you think here. So when you're calculating the median, unless your brain computes math very quickly and easily, I would encourage you to actually write out the numbers in order. So median, as you may recall, is the middle point of our data set. It's the midpoint of our data set. So if we are calculating this by hand, that means we have to have all of the numbers mapped out in order to figure out what is that middle point. So I would encourage you to actually just physically write down the numbers in order. So that's what I've done here. So I've got my 1 up here, I've got my 3s, got my 5, got my 8. So now it is much easier for me to identify that the middle point is 3. So this is the middle point of my data. There's 2 scores above it, 2 scores below it. It's smack dab in the middle. My median is 3. So of course, the mean, as you may remember from our previous calculation, it's a bit more comprehensive because it takes into account every single score in our database. The median is just the middle point. So you might be thinking of examples where, like, okay, so this one person had 8 candy bars. What if somebody else had like 20 candy bars? That would really affect the mean. The mean would very much show that. However, the median wouldn't change very much at all. So the median is a helpful, again, it's kind of like a helpful way of continuing to illustrate the commonalities, the shared kind of central aspect of our data set. And it doesn't include every single number in the data set. It's just simply like, where's that cutoff point? So sometimes it can miss if there is an extreme median, or if there is an extreme situation, like one person, if I interviewed person number 6 and they had 20 candy bars, the median is not going to take that into account. So here's one of the reasons. This is one of the reasons why we have these different measures of central tendency and variation. So median would be 3 here. Tells us a little bit of information, not a ton, but it is a common measure that is reported quite often in people's research. So it's helpful to understand what it is. The mode. The mode is even easier. This is the best one to find. You just have to look what number is the most common here. We've got 2 3s. That is the most common answer. Our mode is 3. So again, all 3 of these data sets are sort of telling us different information. The mean is telling us the average. It's including every single number in our calculation. The median is simply that middle point. At what point are there equal amounts of scores above and below? And the mode is the score that's showing up the most often. So they all tell us a little bit of information about what are the common aspects of our data set. What does our data have in common? What do people who are responding to this survey have in common? All right, example number 2, hourly wage of high school seniors. So we have person number 1, person number 2, number 3, number 4, number 5 again. Here is what their hourly wage is. Hypothetically, I'm making these people up again. So we want to calculate the mean. Here is our equation. And I should have covered up those numbers for you, but we're plugging it in anyways. So here is our mean, and we want to add all of our scores up. We want to divide them by the number of people in our sample. So I'll give you a second to work that math out for yourselves. Again, use a calculator if you're more comfortable that way. Hopefully you added them all up and got 50. We're going to take 50 divided by 5, and we get 10. So our average here is 10. $10 is the average hourly wage of these 5 high school seniors that I hypothetically interviewed / made up. Median. Again, helpful to map out those data points. So see if you can figure out what is the median here. Pause the video if you need another minute. All right, so when I map out these numbers, I can see that middle point is going to be $10. So $10 is the average, $10 is also the median. Now how about mode? That's an easy one again. I can see $9 in there twice. Super simple. We're trying a couple easy versions of this, and then we're going to step up the complexity just a little bit. Okay, next measure is the number of times each dog licked me at the dog park. So in this example, I hypothetically went to a dog park and I got licked by 5 dogs. Actually, I guess I only technically got licked by 4 of them. Dog number 4 gave me 0 licks. I don't actually like dog licks, let me clarify that too, but you know, you got to keep things interesting with statistics. All right, so here are my 5 dogs. Here's how many times I got licked by those dogs. Here is our equation for mean. So see if you can calculate this out yourself. So hit pause on the video right now, get your pen and paper, hit pause on the video, and I will give you, actually you'll give yourself rather, time to calculate it. Tune back in when you're done. All right, so hopefully this is how you have mapped out your equation. Hopefully it added up to 20 out of 5. And hopefully you got a mean of 4 licks. So on average, I was licked 4 times by the dogs that visited me at the dog park. Median. Map out our numbers. Again, pretty easy in this example to calculate a median of 4. Mode. Now, what do you think the mode is? This is a trick one, huh? So this one has 2 modes. We've got 4s and we've got 6s. So it is totally okay to have more than one mode. Very often we will find this to be the case, in fact. So in this example, we have 2 modes. So quite often we'll find researchers end up with 2 modes. Yeah, especially if they're asking a lot of people the same question, it's very likely that folks are going to answer in the same sort of way. Okay, now we're going to step this example up a notch. Here we've got mean, median, and mode again. This time we have 8 dogs, a little more complicated. And there's a trick with the median. So hit pause on the video, give yourself some time to practice these equations, map out the mean, map out the median, map out the mode, map out your calculations. Hit play again when you're ready. All right, hopefully you have taken some time, calculated your answers. Let's see what we've got. Here's our lovely equation for mean. There are all those numbers plugged in. This time we've got 8 dogs that we're looking at. We add those numbers up. Hopefully you got 40 out of 8. Divided by 8, 40 is 5. So we've got an average of 5 licks this time. With these 8 dogs, I was licked an average of 5 times by the dogs. Now median, a little trickier, right? When we map out those numbers, this time I have given you an even number of dogs. So that means that we end up with 2 numbers in the middle of our data set. And if this is confusing for you to try and figure out like where's the middle point, I would say like start at the outer ends and just work your way into until you match up in the middle. So start with the 0 and the 9, go to the 4 and the 7, go to the 4 and the 6, and then end up at the 4 and the 6 in the middle. So sometimes it can help from that sort of visual lens as well. So this time we have 2 medians. However, because this time we're not looking at the most common response, we're not looking at their responses, instead we're trying to figure out what's the middle point of our data. We want just one median. So we have to figure out how to get this down to one median. So perhaps you know the answer to that. If you don't, I shall show you. We start with 4 and 6. What we do is we simply take the average of them. We simply take the mean of these two numbers. And now we know how to do means, so isn't that handy? We add them up, we divide by the number we've got, which is 2. So we add 4 plus 6, which is 10. Divide that by 2, we get a median of 5. So you could also look at those numbers and be like, okay, what's between 6 and 4? 5. So if you figured it out that way, that's totally fine as well. Sometimes we do have to do the math though, especially if those numbers weren't quite so, if I didn't make it quite so easy for you, we'd have to do a little calculation of our own. So when we have a median, when we have more than one median, we want to narrow it down to just one calculation. However, it is okay if we have more than one mode. How many modes do we have this time? We've just got one. We've got a mode of 4. In this calculation, we end up with a mean of 5, median of 5, and a mode of 4. So it tells us like our data is pretty similar. The mean, median, and mode are pretty similar to one another. So we're looking at a fairly consistent data set here. We have, a couple outliers with 0 licks and 9 licks, but in all our data is pretty similar to one another. All right, that concludes the video on central tendency. Tune back in for measures of variability.